Our problem statement is to design and manufacture a fuel-efficient, lightweight drone that incorporates the speed of a plane with the precision of a quadcopter.
Hi, so my name is Paul Feiner. As a member of the VTOL group this year, I've been working on legal research. I've been researching the FAA guidelines and learning how they apply to our VTOL project, learning when we can fly, where we can fly, and then as we apply the VTOL in a commercial aspect, how we can only fly at a certain height and how the guidelines restrict us from flying out of sight. And then we've also been researching the classification of our project. Obviously, our project would be used as a commercial use once applied in the business world, but right now it's just a private hobby style of use. And then I've also been working on safety guidelines for our group. We had some issues earlier in the year where we were not promoting safe ideas and promoting safe concepts when we went to fly. So we had to restrict our flying capabilities and how we were flying and implementing some safety guidelines. And then also I've been working on our business partnership. I set up our business meeting, our very first business meeting with Casey Adams of Kansas City Drone Company. I contacted him and started our kind of a mentorship / partnership program with him. And I think that really helped get our project off the ground, and taking it forward, it provides a lot of insight from an actual business.
During CAPS, I have been working on practicing flying. On 3 computers in the aerospace room, we have a system called Real Flight. On Real Flight, we have plane, helicopters, and drones, different ones that we can fly. There's also different maps that we can fly on to improve our flying. There are some games that we can do, like obstacles and collecting coins in a certain amount of time. We have to have a certain amount of hours before we can fly outside. I have also built a foam plane that I can fly outside, and I have flat mixed that plane with the controller, and it also has one propeller. I go fly out in the big field on the other side of the street by CAPS. It has been somewhat successful, but we need to also have more flying time to make sure it is more successful. And also in the near future, I would like to build some more foam planes to better my flying, and also to be prepared to fly the real VTOL drone. To finish his
I gave one of them to Seth, and he counted it and 3D printed it out so we can mount the motors. And after he did that, I got it flying and been practicing on that. Also, I've been practicing a couple hours a week on the flight simulator to get some good practice in. And recently, me and Dawson have started building our own planes so that we can practice on the planes. Once the VTOL gets off the ground, it's going to transfer into forward flight, which will fly like a plane. So we have to practice on the planes. We got our foam flight plans off flighttest.com. They have great plans, and all we do is print them off, cut them, and we tape them down to the foam board and cut them out. Once we cut them out, we have to gather all the electronics and put the electronics on and hook everything up so that it works right. And once we do that, we can go test fly it and see if it flies.
My name is Cameron Bates, and I'm in charge of the H-frame. And what that is it is a prototype with all of the wires that we will be using on the finished VTOL project. So what the H-frame is we have all wires, and we have a working quadcopter. Then we'll take that, and we'll actually put it onto a foam body, the actual VTOL body. Another thing that was really hard to do was the APM system. Now the APM system was a complete nightmare because we had no idea what we were doing in the beginning. It took about a month to fully realize what it is, and what the APM system is it's the GPS connecting with the actual quadcopter. So this means we'll actually know where the quadcopter is on the world. This way we can actually fly autonomously and set routes for it. We don't want everyone to actually have to fly this, especially if we're going to be working with Amazon. And with Amazon, we can set it automatically to fly to a house and deliver a package. The H-frame was very difficult to do in the beginning because it kept breaking. And it kept breaking because the motors would arm or spin. And we messed up outputs to the motors, so the motors weren't reading correctly. So that's good. And we fixed most of the problems. The only thing left we have to do is fix the outputs, which should be done by the time this video is out.
So the project that I'm on at CAPS is the VTOL drone project, as you might already know, and that stands for Vertical Takeoff and Landing. And so basically it's supposed to fly up in the air, then the motors will switch over to forward-facing ones and fly like a plane. And it's supposed to combine the speed of a plane with the efficiency of a quadcopter. Now, basically what I contribute to this group is I'm on the pilot team, so I practice on the flight simulators a lot, but I also handle a lot of the business aspect of our project. For instance, our business partner and sort of our mentor is Casey from Casey Drone Company, and we've been working with him a lot, and he's been giving us a lot of feedback on our drone and what we can fix to make it better. For instance, one of the problems that we were having is the APM system, and he just volunteered to give us one of his extra ones to see if it would work. So we're actually going to be using one of his systems to fly our drone. We went downtown to his workspace a couple weeks ago, and it was really interesting. He does a lot of work with drones, and he knows what he's talking about. Aside from that, I basically help with a lot of the brainstorming and inventing and idea making behind our drone. I really provide our group with a lot of entertainment and just a great work environment. Every group needs that, and I feel like I do a great job of giving that to everybody.
So I'm Jacob, and I've been the lead on the manufacturing side of things. So I've been working in the shop to fabricate the various parts we need for prototyping our designs. Like I made the wooden prototypes for our tilt rotor design and cut that out in the shop. We've been working on this clip design, which will hold various instruments we want to hold in our VTOL. So our tilt rotor design was a design that basically tilted our motor forward so that we could fly horizontally, and then tilted it back up so we could fly vertically. But we had to scrap that because it would be too hard to land. One thing we wanted to accomplish this year is that we wanted to cut out some more foam bodies so that we could continue to practice. But a problem we ran into was that the foam cutter was malfunctioning. And basically what happened is that we made a side profile CAD drawing of our wing that we wanted to cut out. And then when we imported that drawing into the format we used for the foam cutter, it was basically completely broken. There were like crazy lines going everywhere and all sorts of stuff, so it didn't really work. And we researched a lot online, but it's a pretty rare program. It's not used very much, so there wasn't a lot of help we could find, and we are still trying to find a solution for that, but we haven't been able to. So
I'm Steph. I'm the temporary group leader after we had a conflict of ideas with Arash. I've been working on the mechanical design team, working on the tilt rotor, designing it. We've also been working on the new design for our VTOL after the tilt rotor was proven to have needed a lot of overcorrectness in order to work properly. So we have 2 motors in the front and 4 motors on the side using 2 RG pilots, and we're basically going to have 2 controls. In addition, I've also been working on a bit of the programming side, getting the tilt rotor originally, when to stop the tilt and when to start it again. But after we created our new design, we've been working a lot more on finding out and building our bodies together. With the 2 motors, we've been cutting little slits in the front side. We're still using the basic tilt rotor design, except we won't have a servo on the end to turn it. And that'll just hold the 4 motors on the outside connected to the wires properly. And yeah, I've been working on a lot of the CAD work, and basically been keeping this group together.
Hi, I'm Ian, and as part of the VTOL group, I've been a big part of the design and coming up with the ideas for a lot of the tilt rotor stuff. So I've been originally, as some of them may have already told you, the tilt rotor basically had to go up and down. So I was doing a lot of the CAD work for that, and so when we came up with an idea, I would CAD it and get the dimensions right so that we could properly install it onto our existing machinery, and then we could use that and test that in CAD to see if it would work. So I was working a lot with CAD, and then I also had to do the group last year had some files in CAD that had all their parts and all their wings and shapes and dimensions. but unfortunately somehow a lot of those were messed up, so the dimensions were actually not correct. So I had to remeasure those and recad those and change the scaling so that it was actually proportioned correctly. So that was a lot of my job this semester. Another part of the design that I was a part of was the clip. And the clip is basically a device that we had to create that can have multiple different recording objects attached to it, such as crop surveillance devices and cameras. So basically, the problem with the clip was we needed to come up with a compact and lightweight device that we could attach to the VTOL, probably on the bottom. But that in turn, we could attach multiple other devices to, so that they would be able to measure things and that we would use the drone for all of its intended purposes. So I played a big role in the brainstorming and trial and error of this, and had to come up with a lot of ideas. And we finally narrowed it down to a great option that we think will work very well.
Can you just introduce your company and kind of like what you do and how you started and stuff like that?
Yeah, so I'm Casey Adams. I'm with the Kansas City Drone Company. We started September 2014. I've got 7 years, I think, experience with the DoD flying, building programming, flying various UAVs. Let's see, I've been throughout Africa. I've been to Egypt, Sinai Peninsula, Israel, Afghanistan, the UK, doing all this kind of stuff. So I've been around, so I got some experience.
And what services does your company provide?
Good question. FAA pending a lot. Right now we have an exemption to fly for agriculture. So we do ag mostly right now. And we have amended our exemption to do a bunch of other things. We're going to get into construction, industrial mapping, land development, insurance.
Okay.
We're going to do a lot of different stuff.
So how did you first get interested in drones?
I was in Egypt with the Army, sitting in a guard tower, and I was bored out of my mind, and I saw a bird that didn't flap its wings, and I thought, well, it's not that windy. I was like, that's weird. So I'm just watching this bird, and it was an Israeli drone, and they weren't supposed to be there. So that's part of the treaty that we're enforcing, is reporting aircraft. So they were flying illegally a drone over the area. It was something like 200 miles over the border. So it was in there, like it was out. So so yeah, we reported that whole thing, and I don't know what happened, but ultimately that's what sparked my interest, and I was kind of obsessed after that.
Okay, wow, it's neat. Okay, so recently the CAPS program and my group specifically kind of came to you for a little bit of help and advice, and kind of why did you decide to kind of help us out and mentor us a little bit?
Ultimately, what you guys are doing with the CAPS program is what University of North Dakota and Kansas State University are teaching their 2-year students. So what you guys do in the first 3 months of your program is the last 2 months of the second year, their sophomore year of these other large institutions.
So as you know, we are building a different type of drone known as the VTOL drone because it takes off vertically and flies horizontally like a plane. And in your opinion, is that better or more helpful than a normal quadcopter type drone? And if so, why?
Yeah, of course. I mean, everybody's looking for that aircraft that has the best of both worlds, right? It takes a lot of energy to spin essentially airfoils around to create lift. The hover and stare capabilities, as they say in the military, they're fantastic. You know, everybody likes the idea of hovering and getting a perfect shot, whether you're shooting movies or whatever. But if you can create something that vertically takes off and lands, then you've reduced your logistical footprint, and the amount of money that goes into doing that has reduced drastically.
So what direction do you think the VTOL will be heading in the future?
Vertically.
What do you think the future of drones might be, or where it's going next?
IoT, connected UAVs. So right now, Ag Eagle is a good example. They fly via the cell phone towers, right? So that's the command and control link, is this little black Verizon dongle that sticks out.
Okay.
So all of it is controlled with my phone. So if you have to hand control it, you screwed up the flight plan somewhere. There's an emergency, you know, that if you hand control it, you're wrong, but hopefully you can save the aircraft. But the idea is swarm capabilities open up, transparency opens up, so if the FAA wants to keep tabs on UAVs, I mean, everybody's connecting UAVs to their phones. So if your UAV, let's say it's a quadcopter or whatever, is reporting its position to your cell phone, your cell phone can repeat that position to the internet. And there's no reason why the FAA or anybody else can't get on and check the status of the airspace in those areas.
On kind of a civilian level, just flying drones. I mean, they say drones are going to be one of the hottest Christmas presents this year. I mean, everybody's going to have them, but what do you think is required to be able to fly it effectively and safely?
I got a call from the Kansas City Star, and I have a habit of speaking off the cuff, which is not always a good thing, right? And I'm glad they didn't print it, but what I told the Kansas City Star when they asked the exact same question about there being sales of drones, there's an estimated 700,000 UAVs that are going to be sold just in the United States for Christmas. And I said it was going to be an effing disaster. So they're so susceptible to RF frequency interference, magnetic interference, harmonic interference, and nobody knows what that means. And that's the problem. And that's why it's a disaster.
Okay.
Because we've got, if you look outside my window right now, and actually on that window over there is a Wi-Fi repeater, runs off of 2.4 gigahertz, right? Well, that's what this runs off of. That's what everybody's crap runs off of. That's what my garage door runs off of.
Well, thank you for your time. I think that's all the questions we have, and good luck to you and your company.
Thanks, appreciate it.
Our plan is to immediately designate a team to hand cut the foam body in order to place the working guts into it. This way we can have a VTOL prototype body on which we can conduct all our physical tests. Then, to have 2 people developing a system of communication, ranging from programming and researching the parts required to it. IoT connection and developing a final body is priority number 1. Next priority is manufacturing and attaching the clip which we already have on Autodesk. The only setbacks we are unsure of at this time is the foam cutter, and we could solve this easily by having an outside company cut it for us for relatively cheap. Overall, I think we have the capability to easily progress the VTOL further than we initially thought.
In the future, we hope to start transitioning from the production of the VTOL to the uses and accessories it was intended for. For example, one of the strong recommendations from Mr. Adams was IoT communication capability, which allows multiple drones to complete a task cooperatively and thus more efficiently. As this project moves forward, our main goal is to develop these bodies and incorporate sensors or cameras that will map a certain area.
Okay, everybody, thanks for watching our video. Hopefully the VTOL will be up and flying and fully functional by the beginning of next semester. And if I'm still here, I will report back to you then.
Chris.
So
now we can go into the process of Dawson. Dawson, we gotta get this done.
One day, Liam just comes up to me, and he just asks me to make a kill switch, and I'm like, I don't know what a kill switch is. So then he tells me what a kill switch is.
Well, hello everyone. I'm part of the H-frame. God, it's cutting off my hair. Take 4.
Take 4.
I'm in charge of the VTOL project. Take 5.
Take 5.
My name is Cameron Bates, and I'm in charge of the... And what that is it is a prototype with all of the wires that we will be using on the finished VTOL here.
Okay, so one problem that we faced was that the foam cutter we were going...
I forgot to do it.
That was stupid. In the near future, I'd like to build some more so I can have a better flying and I can be able to fly my VTOL drone. And my favorite thing to do at CAPS is